Then we have a lot to get through in the next hour. So I'm Jeff Van Humen, OCE Business Development Manager, and I'm pleased to welcome you to our webinar on rebuilding local supply chains, specifically in the area of mask manufacturing. We have an amazing group of speakers that I'm looking forward to introducing you to shortly. Let me start off by thanking you all for joining us today, and we are all hopeful that you, your families, and your teams are all safe and well during this challenging and difficult time. At OCE, we are now into week 10 of our work from home, I don't know if you want to call it routine. This is the first time I put on a suit jacket in 10 weeks, so it's certainly not anything but routine. Next slide, Kim, please. For those that are just learning of OCE for the first time, we are a provincial government affiliated organization that is accelerating innovation through game-changing research that leads to successful commercialization outcomes like increased competitiveness, revenue, that ultimately leads to jobs for all companies in Ontario. And by that I mean startups, scale-ups, SMEs, multinationals. That is certainly a portion of what we do at OCE. But we also think of ourselves as a pan-provincial dot connector. And you can see this through this slide, in which over the last 5 years, OCE has supported projects in over 160 communities in Ontario. There's a mighty team of business development managers like myself across Ontario that are ready to support you in your innovation agenda journey. Please just ask us. Next slide. I've been privileged to continue to work with a great group of colleagues on the development of strategies to support all aspects of the COVID-19 pandemic. From that work, and as part of our pan-provincial dot connecting approach, we established our COVID-19 collaboration platform. This is a one-stop opportunity to share if you are a provider of products or services, or if you are a seeker. Not in the Harry Potter sense, but rather an organization in need of a product or service. Behind it all, my business development colleagues and I were busy finding ways to help facilitate or curate these dot connections. Next slide, Kim. The platform was an excellent opportunity for industry partners, regional innovation centers, and research partners to come together and support the platform. Thank you all. We're happy to report that almost 340 participants accessed the platform, which translated to over 400 connections made, and we aren't done yet. Next slide, Kim. Which brings us to why we are here today. Today, we wanted to share some of the work on rebuilding local supply chains in mask manufacturing. And as we all know, the COVID-19 pandemic has highlighted the need for establishing a Canadian domestic supply that is sustainable for PPE. We're going to provide a glimpse, and just a glimpse, into one example, but could be applied to any PPE. What we will share today is not the final solution, but it really is an example of where we go from here. We've intentionally identified masks as our subject today, generally masks. But please note that there are several different types of masks, including N95, surgical, and community or personal masks. These will all be discussed today. The agenda will run as if you were developing your own mask manufacturing capability. So to kick us off then, Jean Girard would be the business unit manager for Texel Technical Materials, will provide us a glimpse into the production of mask filter media materials. Then Merrick Levine, president of Ontario Dye International, will speak to us about his journey to become a manufacturer of surgical masks. Then he will be followed by Derek Wild, industrial hygiene specialist, will then share the Cambridge material testing story on how to get your mask tested for compliance to the appropriate standards. Finally, Professor Ravi Selvaganapathy will then bring us all together based on the amazing work being done at McMaster University. We'll then have an opportunity for question and answer to follow. So please feel free to input your questions at any time during the session. You know, at the bottom of your screen, you'll see a Q&A portion. Please just include your questions there. Next slide, Kim. So let's get started, and this is where we begin. So Jean Girard is the business unit manager for Texel Technical Materials. Jean, please take it away.
Well, good afternoon, everyone, and thanks, Jeff, and thanks for everyone who have come here to the webinar. So a little background, Texel was founded back in 1967 as a needle punch manufacturer. We have grown our business through different platforms: geotextile, filtration, medical, industrial, and automotive. We have now over 300 employees. We've always been focused on quality, product development. We have an international presence, and in liquid filtration, we are recognized as the quality leader, even in China. We became part of Lidl back in 2016, manufacturing in Europe, Asia, and North America. This company is over 3,000 employees into the automotive, sealing, and advanced filtration. And we also have in our portfolio melt-blown that is being made in USA and France. And we currently support over 50 OEMs, including a top 3 mask maker. So let's go through the first page of the presentation, please. So on this first slide, you'll see, the range of what we currently have in the mask manufacturing, from more protection, being the respirators and the N95, to the medical mask as a better protection, and finally the general purpose mask. Most of them, as you see on the right side, are being made by multiple layers. One inner layer called comfort layer, and one outside layer called protective layer, to prevent anything from the water from going through the filter media, with the middle part, the filtration efficiency layer, being made of 1, 2, or sometimes even 3 layers. So the difference between respirators and face masks is basically the respirator protects you from contaminants in your environment, and face mask protects the environment from yourself. So in one case, you have to have a tight fitting in respirators. You have to make sure it's going to be less breathable because of the tightness. And it is designed to block, or tested to block, particles that are 0.3 micron and sometimes smaller. And during the physical testing, filtration efficiency will be measured, breathability, the leak coming from any of the valve, and how tight or how fit that the mask is, or the respirator is, to your face. And these are mostly known in Europe, in North America, under the N testing for the NIOSH, and FFP is the European counterpart. On the face mask side, well, you have a somewhat of a loose fitting. Breathability has to be higher because you're going to use it as you walk, and it's to protect you for half a day or a day. Again, I mentioned the test that it is to protect the environment from your cough and sneezes, and the test mostly is performed at 3 microns, so about an order of magnitude larger than for respirators. And in the case of the medical, if you go in the medical side, you'll be tested under bacteria filtration efficiency, that's 3 micron. A further testing on particulate filtration efficiency at 0.1 micron. Then we'll go into blood splash, flammability, pressure drop, and so on. This is referred as the ASTM or FDA level 1, 2, and 3. So this gives you an idea of what and how we make the face mask. On the next slide, on the left side, you'll find the construction of your typical melt-blown equipment. There aren't currently any manufacturer in Canada of the melt-blown. It is the most, it's the most used type of media for face mask, and basically has the polymer comes through the nozzle, there's a filament that will be put on a backer, and it will be stretched, and you can, if you manage the equipment, you'll be able to, it's called fibrillation, so you're generating a lot of very fine fibers, and as you see in the bottom, the size of fibers are extremely small, and it is currently the bottleneck of the supply chain is the melt-blown, because most of the production of melt-blowns in North America was dedicated to non-surgical mask. The melt-blown production has concentrated in China. I read recently that 85% of the face mask manufactured before the pandemic was made in China. Sinopec is adding more capacity up to 12 needle punch, not needle punch, sorry about that, but melt-blown equipment by the end of the year. And including Lyndall, there's only 6 North American suppliers with no melt-blown manufacturer in Canada. What you see also at the top right side, that was provided by a study by INDA, a non-woven association in the US. And of course, all they provided was the US hospital number, but you can see just on either the surgical mask or the N95, if we go to the mid-range, a mid-range surgical mask in the US would be, the need per month would be about 500 million. The need for N95 about 125. So and then using a rule of thumb at 10-to-1 for Canada, you come with 50 on the mid-range for surgical mask a month, and then on the N95 you're about 12 and a half. But that translates into kilogram per month. And then you see at the bottom that currently, you know, the need during the pandemic, on average, is anywhere from between 300 tons to 457 tons of material, and it keeps growing. So as we go into, this brings us to the next page. Well, what are the main challenges and on the domestic supply side? So, as I mentioned before, pre-pandemic media came from Asia, where the market price was just too low for North American suppliers to follow suit. The latter chase more technical application because melt-blown can be used in cabin air, oil adsorption, liquid filtration, and many other type of filtration. As the pandemic touched every single country, melt-blown had to be sourced in North America, and generating quickly a demand that's basically in a very short time, about 10 times the amount of output from our current melt-blown lines. And the larger North American melt-blown supplier were quickly swamped over, and new lines commissioning went from anywhere from 3 to 12 months. I think currently they are close to 12 and beyond for a melt-blown line. So when we look at the domestic demand and homeland security, as the demand exploded and shortage appeared in all countries, government had to step in and regulate it. Face mask manufacturers were asked to supply domestic market and stop exports. For example, 3M in USA. And even today, the USA and other European countries have forced supplier of melt-blown to cater only to domestic needs, and it's still the case. You know, most companies will have a number of criteria. If it is government contract, it scores a high note, and then it has to be domestic, and only supply can be exported if you meet all the domestic demand, and if you're or if you are a current customer. So Canadian face mask, yes.
1 minute.
Okay, so I need to speed. I thought I was going fast. I need to speed up. So Canadian face mask converters have struggled to honor the contracts with federal and provincial government. So we had to face frauds. Quebec was saved by one. Interpol saved another one. Also, counterfeit has entered the market. And as for moving forward, the demand for general purpose is increasing, and our reserve eventually that remains our weakest point. So as we move to the next slide quickly, it brings us back to three options. Making Melblot in Canada, we could make it even if and then participate in supplying other countries, as the demand solely for Canada may not be enough. Or design a filter media for the medical application, although you have to face a price that's going to be about 24 cents a square meter. Or do what other countries have done, which is started to have a lower level of standard for the general purpose instead of the 95, and come up with a solution like we did a few weeks ago, and developing a BFE that's going to be greater than 95 with a homegrown electrostatic filter media. And we also have another design that reached 75%. So all in all, when you consider everything like this, you know, we need to not only secure the face mask making industry in Canada, but we also have to secure the manufacturing of the Melblot, because you know, whether it's now or in a year or 10 years from now, we'll be back in we're going to still be in the same boat without any new asset coming on board. So it is, I think it's a matter for Canadian to be self-sufficient, and it's a matter that needs to be addressed shortly.
Okay. Thank you, Jean. I do really appreciate that. So excellent summary. Just as a reminder to those on the webinar, if you do have a question, please add that to the Q&A. I know that some are looking for a response now, but we do have a time period near the end of the session that we will be addressing as many of those questions as we can. So next slide, please, Kim. So next up, we have Merrick Levine, President of Ontario Dye International, who will share his story. Merrick, please take it away.
Okay, thanks very much, Jeff. So first of all, I just want to say a very big thank you to the OCE. Jeff, we've been in touch now, I think, for the last 4 weeks, and the support of OCE has been fantastic. So without your support, we basically would not have been able to get to where we are.
Demain après-midi.
Sorry, there's somebody. Sorry, can somebody just mute their phone?
À 3h30 serait correct.
Jean, is that you maybe? Sorry, Merrick, just, I think, Merrick, just try that once again.
Sure, do you hear me okay?
I can, yeah, apologies.
I thought there was a French translator translating what I was saying.
Maybe. Anyways, just carry on, please, and thank you for those kind comments.
Sure. Yeah. So yeah, I've been invited just to speak about the response that Ontario Dye has taken during the COVID pandemic, and we've sort of we've taken it in 3 different paths. We've manufactured dyes that have been used to make PPE on Canadian soil. We've also we've been importing face masks from overseas, and that's been quite an interesting journey in itself. And we've also been through the process now of acquiring manufacturing lines so that we can manufacture our own medical and non-medical face masks in Canada. So at the beginning of the pandemic, when it started to reach Canada, we quickly reached out to the community to see how we could help, because Ontario Dye makes steel rule cutting dies, which are basically just industrial strength cookie cutters. And the idea was that, you know, we make these custom made cutting tools And it's really just a matter of whatever pattern we're provided, we can build the tools for. So we reached out to the community, some of our suppliers and also some of our customers, as well as local community groups, to see if there was anything we could do to help. And right away, we got paired up with groups of sewers, customers that were doing cut and sew operations, face shield manufacturers, medical students who are trying to support the local healthcare workers. And it's been a very interesting experience for us. It's very unfortunate, the reason for us to have to get into this, but it's also been really exciting and really interesting getting a glimpse into the operations of our customers or suppliers. So yeah, we started to make cutting dies that were used, to cut scrub caps and parts for hospital gowns, face shields, fabric hand-sewn masks. We also started to make our own face shields to protect our own staff and to ship them abroad to our other manufacturing locations. And it's been a really interesting learning experience. Mostly to see the way that people step up and are willing to offer floor space, engineering support, sewing machines, drivers. It's really been fascinating to watch and to be a part of. So that was our role on the PPE side from the beginning. And we've also realized that we could probably get into the mask manufacturing space, but also understanding that that takes time to retool. We thought as an initial step, we could start to import our own face masks from leveraging our networks in China mostly. So to date, we've imported 500,000 masks, and the purpose of importing them has mostly been geared towards the civilian population, as well as the manufacturing sector to keep our workers safe, and the workers that belong to a manufacturing peer group that I'm a part of as well. So this has been very interesting as well, because the market right now for face masks, first of all, starting in January, February, it became a real cottage industry in China, that suddenly people were going out and buying manufacturing equipment and starting to pump out masks. And what you see as a result is high fluctuation in the cost of raw material. You see a lot of quality control issues, and you see a lot of export challenges, and wild fluctuations in things like shipping fees and delivery time. So we started to learn about, specifically what types of masks are required, what to look for, how to do quality control on the ground in China, how to get the masks secured, and how to get them out of the country. And getting them out of the country in itself has not been easy. It takes late night negotiations and switching ports and all kinds of hedging your risk by engaging multiple suppliers. And it's been very interesting experience, but ultimately we have been able to secure 500,000 masks in Canada. Almost all of them have been distributed already, and we're looking at bringing in more. And then our sort of the most challenging front that we've been working on is the manufacturing equipment itself. So the equipment, the goal is really just to create a stable domestic supply chain. And the way that we've been doing that is we've identified machine suppliers. It's been a long vetting process. Our first manufacturing line is set to arrive at Pearson Airport tomorrow. And we have a second one that is being shipped by ocean. And we're looking at possibly purchasing 5 more. So the goal within the manufacturing of the masks, we're also taking 3 streams there. So the very first goal to meet the immediate need is to manufacture the general purpose mask for civilian use, which, as Jean had explained earlier, is it's really based on the bacterial filtration and particulate filtration efficiency levels. The next goal would be to achieve a mask that would be at ASTM, thanks Jeff, ASTM level 1 standards. So that would have a higher particulate filtration efficiency. And then our third goal would be to engage in R&D ventures, specifically looking at manufacturing masks that have antiviral and antibacterial properties within them. So that type of collaboration will be through some commercial suppliers that have already come up with novel solutions, as well as academic bodies that are looking into this. So we are, and our first line will arrive tomorrow. Right away, we're actually going to be stripping it of all the wiring and configuring it to the Canadian safety standards, and reconfiguring the PLC. And so the goal is to build very robust production lines. And we ultimately think that in about 4 weeks' time, we'll be able to produce between 250,000 to 500,000 masks per week.
Great, thank you. Thank you, Merrick. And maybe Kim, if you just want to push the slide ahead one, because I think there is a Merrick.
Oh yeah, this is just an example of a typical manufacturing line for making the 3-ply disposable masks.
Wonderful. Thank you, Merrick. Do appreciate that.
Thank you.
So next up, we have Derek Wild, Industrial Hygiene Specialist from Cambridge Material Testing, and he'll share how you would get your mask tested in compliance with the available standards. I know that there's several questions with regard to testing that are already coming up, but hopefully Derek will be able to address some of those. But Derek, take it away.
Thanks, Jeff. And thanks again to OCE as well for putting this together, and so that we can obviously all share and discuss the need for testing masks as an example. So Cambridge Materials Testing has been around for about 35 years now. It's a ISO 17025 accredited laboratory. We have 2 locations, one in Mississauga, one in Cambridge. Based out of Mississauga, where we do the mask testing here. And we started getting into this about 6 weeks ago when basically the need arose and everyone was asking about it. So medical masks are a type 1 medical device, and so need to go through ASTM F2100 testing. Those are those 3-ply masks that cover the face and are meant for isolation settings or for nurses. The respirators, on the other hand, is a different beast altogether. They're the either the KN95 or those N95s that you've been hearing a lot about over the news that are tested to NIOSH standards. So if you want to advance to the next slide. So this is the requirements for medical masks, those 3-ply type. There's 5 different tests. There's bacteria filtration, differential pressure, particulate filtration, blood penetration, and flame spread. This is the 2019 edition. There was a 2011 edition that is referenced by government, it seems. The difference being the differential pressure measurements are a little bit tighter, I guess you could say. You see that there's 3 different levels there, level 1, 2, and 3. The 2011 edition was less than 4, less than 5, and less than 5. So what's happened here in the 2019 is there's what is it, a little bit more room for breathability, allotment on the materials. I'll go into each test a little bit further, but the premise of these standards is to determine acceptance of the mask to an acceptable quality limit of 4%. And so for the blood penetration test, the resistance to synthetic blood, as an example, you have 3 different pressures where you're basically applying blood to the surface of the mask. And you want to see whether or not 29 out of 32 masks that you're testing don't have any blood that passes through the material. 28 would be considered a fail, where you would basically test possibly at a different pressure, maybe at level 2 or level 1, as an example, to see if it passes that type. So yeah, moving on to the next slide. So this is the European method. You'll see it sometimes referenced on packaging and or boxes. Various clients are asking for one method or the other. The bacteria filtration is the same from one method to the other. Sometimes you're just referencing an ASTM or an ISO methodology. The pressure is different. Again, that has to do with the breathability of the fabric. Splash resistance, that's the blood test. There, it only goes up to 16 kilopascals, which correlates to a level 2 ASTM. So you don't have a level 1 and you don't have a level 3 in terms of a reference there to go on. And then you have microbial cleanliness requirements. So next slide. So this is N95 masks now, which would be those types of the 3M models as an example that are certified to NIOSH standards. And so sodium chloride is a salt that's used and aerosolized onto the surface of the masks to evaluate the filtration performance through the material. It's tested at about a much higher flow rate than a medical mask is. It's also done to a different methodology. It's for your reference, it's a 42 CFR 84 method in the States, or in Europe, it's EN 149 as an example. I believe also that CSA might be in the works of possibly developing their own methodology as well for the Canadian marketplace. But I believe that's going to be in the works, so not quite yet. N95 masks also require fit testing for the wearer to be performed. That's entirely separate as well. There's also another issue about sterilization of the masks and reuse of the masks and determination of what happens to the filtration capabilities before and after sterilization by different techniques. So this is where the sodium chloride aerosol challenge test would be useful, and the filtration performance like the particle filtration or the bacteria filtration. This test is usually offered by a machine called a TSI 8130 or a ATI 100X, which is all equipment basically offered in the States. So there aren't that many outfits in the country that I'm aware of, at least, that has this capability, us not being one of them. So if you want to go on to the next slide. So this is the for KN95s, which has been hitting a lot of the news lately. Again, it needs to meet an AQL of 4% standard. And if they happen to fail NIOSH test, then sometimes there's the consideration to evaluate about repurposing as a procedural mask. And then you do the other two tests as well, the blood and the flame. Next. So these are the some of the images for the two tests as an example. The top image there is the blood penetration. You basically place the mask on the left-hand side of the image there, and then you have where C and V are pointing, where the blood escapes the cannula and is sprayed at the surface of the material at varying pressures. In the picture below, you have a rough diagram of differential pressure setup, where you take about 1.5 inch diameter swatch of the material, 5 of them, and you measure the pressure differential from one side to the other. Yeah, next. Again, here you have the flame test apparatus as an example. You're burning the fabric to evaluate whether or not it reaches about 6 inches length within about 3 seconds or more. We've been noticing a lot of self-extinguishing of the material, as in it's not burning very quickly. The other image is bacteria filtration, where you're basically aerosolizing a aerosol of bacteria, Staphylococcus as an example, and it's passing through the filter nature material onto a set of agar plates that you then count for colony forming units to evaluate then, in that case, the efficiency. At this point in time, we're not set up to do the bacteria filtration efficiency, but we might be working with someone else to partner with. Next slide.
Derek, less than a minute.
Thank you. So here is the an example of a setup for doing particle filtration. So you have, going clockwise, at the top of the diagram, you have a aerosolizing unit, followed by a dryer to dry the and remove the moisture and keep the particles there that you need to count, followed by a radioactive product to remove the retention on the surfaces of the walls, and then a particle counter. So you're measuring the counts of particles from one side of the mask to the other. All these parameters basically coincide to substantiate the need and the tests that are outlined in ASTM F2100 for medical mass testing.
Next slide. Oh, there we are. All right, Derek, thank you very much for that. Obviously, a lot of hard work going on in Cambridge material testing. I hope that some of Derek's comments have addressed the questions that are already asked, but I know there's a few that are still sitting there. So finally, to bring us to the end of our speakers today, so Professor Ravi Selvaganapathy. Ravi is a professor of mechanical and biomedical engineering at McMaster University, and he's going to share the work that's being done at McMaster in support of mask development. Ravi, please share your thoughts.
Thank you, Jeff, and thanks everyone for attending this this webinar. So you probably know about McMaster University. I can give you a brief background. It is one of the most research-intensive universities in Canada. And we pride ourselves on effective interaction with industries to solve industry problems and to resolve research issues associated with these problems. We also have a very good medical school and a tight interaction with the hospitals in Hamilton, and you would see why that is important in this context. Next slide, please. So our journey started, it's a microcosm of what happened to the nation and to the world. So our journey started with our colleagues in Hamilton Health Sciences. You would see Alison in the bottom left corner. She's in the critical care department in Hamilton Health Sciences in the intensive care unit. And Hamilton Health Sciences in early March forecasted that supply chains were getting tight and would likely break down globally, and therefore there was a need to have a local solution. So we went ultra local, and Alison reached out to us in engineering to see whether we could potentially start manufacturing in the engineering building. Quickly, our associate deans and deans put together a team of people to look into this this problem, and we identified that the volumes necessary are quite large, and therefore we wanted to rope in local manufacturers who could be repurposed for manufacturing, while at McMaster we could identify, say for example, the materials that are needed, the designs that would actually work, and also try to look into testing of the effectiveness of these materials. We also quickly identified that the testing capability was going to be a bottleneck because some of the testing shops in the US, which were okay starting out in early March, were quickly shutting down to outside orders by mid-March or so. So the two goals that we had was primarily to address Hamilton Health Sciences, but what we then found was a lot of requests to expand our services to help many manufacturers from a variety of different businesses. Some were apparel manufacturers, others were in the automotive business, but they were retooling for mass manufacturing. So you'd see examples of that. Nico, for example, and Barbarian are apparel manufacturers who repurposed for mass manufacturing. Woodbridge is an automotive supplier, also repurposed. Talon also repurposed for these mass manufacturing applications. So our expertise, we brought together about 20 faculty members and about 40 to 50 other researchers to form a team that can help a variety of companies with their needs. And we put together testing facilities for particulate filtration, airflow resistance, which helps with the breathability of the mask solutions that were offered, as well as bacterial filtration. Now, these are not necessarily ASTM standard type certification, and as a university we don't necessarily do certification, but what we do is work with companies which are in various stages. They could be material suppliers, they could be manufacturers of the mask themselves, or they could be companies which are in the testing business, to assist them to move their products and services forward. And in that process, what we identify is research and development challenges that we can then go to organizations like OCE and NSERC and ask for matching funding in order to advance these things. And our idea in this is to look at not only the present, where we need a significant amount of mass supplies, but also to help Canadian manufacturers to bring forward a competitive product in the future where things are normalized, and like what Jean was mentioning, the product cost goes significantly down. In that case, value-added products are going to be the way that distinguish Canadian products from rest of the world, and that is where research and development would help, and we want to help Canadian companies which are getting into this area advance those goals. Next slide, please. So in doing so, our Faculty of Engineering wanted to keep this momentum that we've built up and the team that we've built up in order to move forward. So we recently formed the Center of Excellence in Protective Equipment and Materials, specifically for the purposes of helping local industry in Canada to advance technology in this area so that they can be competitive worldwide, and they can get a premium for their product as compared to them being treated as commodity products. So the research thrusts that we have identified in this center are in design and development of personal protective equipment. So for example, you'd see that we also made some contributions in face shields. That's a different topic. But in doing so, and in interacting with our partners in Hamilton Health Sciences and St. Joseph's Healthcare, we came across specific instances where the current face shields don't actually meet the requirements of healthcare professionals. So what we are going back is to redesign newer face shields that will help say, for example, anesthetists or people in the emergency who are closely interacting with potential COVID patients, for instance. And these kinds of design modifications will lead to new intellectual property that can actually advance and make value addition to the product beyond what we are currently able to do. The next goal is advanced manufacturing. Jean identified the need for melt-blown products. So what we wanted to do in the center was to set up a prototyping unit where not only can we look into the engineering behind melt-prone products, but also come up with new formulations, composite materials, graded materials, for instance, which are not currently available right now, but which could be value-added products for materials manufacturers. We also wanted to look into other techniques like electrospinning, which can transform materials which are not necessarily high filter quality, but into a superior filter quality materials. Similarly, we are working with NRC in trying to come up and define Canadian standards, which would be more suited for medical applications as compared to current standards with NIOSH and ASTM. And finally, we want to investigate materials like paper or cellulose and other natural polymers to make these products so that it is sustainable and doesn't lead to climate change and so on. So with that, I'll end my speech.
Thank you, Ravi. Next slide, Kim. Thank you. I do appreciate the work that's going on in McMaster, and clearly there is an opportunity for future development, and we're not standing still. So very good. We're coming close to the Q&A period, so just make sure you get your questions in. As I mentioned, we're going to try and get as many of those questions addressed as possible. So now, if you've been following along, now you have your mass production worked out. You've sourced your materials from Jean. You've produced prototypes. You've received your testing certification or validation from Derek, and you've worked with Ravi to optimize your design of your product. So what happens next? And so we just got a couple of resources here that I just want to highlight. One being the Canadian government website, the buy and sell site, which is an opportunity for you to be able to sell your product into the healthcare industry or healthcare system. And what would be important there is that while you're putting your information and you're uploading the testing results that you have obtained from Cambridge Material Testing or other testing service to allow for the public health to review and hopefully approve your mask for sale into the healthcare system. The other resource that I've just identified here is this rapid response platform. Actually launched last week, and it's become quite an interesting source of buy and sell also, but with the end result not necessarily going into healthcare, but more specifically into industrial settings. Quite a strong group of supporting organizations like APMA, Canadian Association for Mold Makers, Automate Canada, and other BASF as others that are supporting that. So well worth a look there as well. So this brings us to our Q&A. Kim, if you could just move that slide just one more time. I think we're in the Q&A section here. So obviously great number of questions here. Thank you. And so maybe just start off kind of backwards again, and maybe just kind of highlighting a question that Maria has included here. Jean, are you aware of any POs or LOIs that have been provided by the Canadian government for melt-blown? Oh, Jean Girard is on mute. Kim, there you go.
Yeah, not that we know of.
Okay, all right. Okay. That's helpful to know. Thank you. So at this, I think I know the answer, but I saw a recent article, just thinking with you for a second, Jean. Up to 3 billion masks of various types are required in Canada over the next year. I don't know, I didn't do the math from your table, but this is from another report that I saw. In your opinion, do we have the capability and capacity to produce that in Canada today or in a year's time? What would you see?
In a year's time, possibly, but 3 million will be split. You know, we need to find out how many will be N95, how many will be surgical, and how many be general purpose. Okay. Because this demand of 3 billion is quite a lot. Okay. All right.
Thank you for that. Merrick, I know you and I have had a few different conversations about your production equipment. you mind just sharing a little bit about sourcing of material for your operation?
Yeah, it's very difficult. So of course, sourcing the material, as Jean already explained, it's the melt blown that is the most precious material to source. We've identified some suppliers that are able to support us in our initial stages, but the big challenge that we're facing is being able to achieve the ASTM level 1, and we have yet to secure a source for that.
Okay.
So for the general purpose mask, we can get melt blown, and we're testing out some different suppliers, and there's others that I'm interested in as well. I'm actually really looking for help on this. So anyone who can help provide us with material, whether it's melt blown or any form of material that can do the trick, that we're willing to test it and certainly willing to buy it.
Okay, thank you. Derek, obviously lots of work going on in testing for compliance to standards for new masks. But if we actually were to say, okay, so what happens after these masks go into production, or what kind of level of testing would you anticipate once a product goes into production?
So in terms of a quality perspective, in terms of ongoing production, I think that would really be a guidance from someone like CSA or others like that, who are going to say, you know, so many batches or so many lots, and then the number of specimens and samples to take per lot or per batch is required to be tested. In terms of the testing, well, it's really outlined in the methodologies and the specifications. It's it's depending upon what you're producing, right? So it's ASTM F2100 as an example, or it's the NIOSH methodology.
Okay.
Right now, as it is.
Okay, great, thank you. Ravi, obviously McMaster, in my opinion, the creation of a center around PPE, there's somebody who's visionary there that saw that there's an opportunity, and obviously sustainability. I'm going to assume that was you. Is that you, Ravi, that had the vision to do this?
I think it's a team effort, right? So we had very good support from the deanery, our dean and associate dean for research, were some of the primary drivers in this. But I think it is also a grassroots effort in the sense that about 20 to 25 faculty members contributed to various aspects, bringing their expertise in different areas. And more importantly, the research staff in our machine shops and students and postdoctoral researchers. So everybody sort of contributed their ideas. As you know, a university is a non-hierarchical organization, and therefore ideas sort of come up, and then the best ideas sort of win. And I think so. So although I would like to take the credit, I'm not going to do that. It is everybody contributing. That's
okay.
That's the beauty of this thing,
Okay.
and more so from our health sciences colleagues. So they had fantastic insights, which were very crucial in helping out companies to come up with actual designs. So an example would be Woodbridge's mask that they got. So the insights that our health sciences colleagues gave in terms of fit and so on were very crucial in their design processes.
Wonderful.
That whole package is what makes it
okay.
effective.
All right. Fantastic. I'm just going to run through a couple of the questions here. Can a surgical mask be tested and certified in Canada? So I think you can hear from Derek's presentation that in fact, yes, that is the case. So testing can be completed at Cambridge Material Testing, and then the certification would happen through the buy and sell site, and that would be ultimately provided by Public Health Agency of Canada. There was a question in here for you, Jean, just with regard to the type of polymer that's used in the melt blown activity. I know, but I'd like you to share that, please.
In the case of the melt blown used for face masks, is polypropylene.
Okay, great.
I just want to expand on one thing that I may not have been able to address earlier, is the nature of the materials based on some research or information that I've heard or seen is that the different materials that are being sourced to replace others that might not be as quite available. There's additional testing that might need to be performed on them, such as cytotoxicity maybe, or skin sensitization and skin irritation, just to, or leachable characteristics to see how they compare against the benchmark standard.
Good. Okay, thank you for that.
I think just to add to that, the point that Derek made, so in other areas, like in face shield, for example, we've come across latex being incorporated into elastics and so on, and that is a concern over longer duration. So latex-free materials are important. And the other important, we have been focusing on the filter material, but what we often find is that the elastics are equally important, and then the connections are equally important. So from a medical perspective, if the elastic gives out, then that is catastrophic, right? So the filter material may be, say, a percentage less or percentage more. That's a minor issue compared to elastic giving out, and the mask actually comes off. So it's a holistic sort of testing that we need to do. And at the university, that's another feature that we are trying to add, is to incorporate some mechanical testing and lifetime testing of these things, both for new masks as well as for masks that are sterilized. So there's a number of companies which are developing sterilization options for N95. So we're working with them to look at whether if you use those sterilization for, say, 10 times or 20 times, does that degrade the filtration property of these materials? So there, those are important. And hope is that this experience will help us redefine standards, right? So all these standards that we see so far were primarily built for industrial particulate filtration and so on. They were not specifically designed for medical applications. So what we want to do from a research perspective is also look at it from a medical perspective and define effective standards that actually give a better indication of the performance of the mask in the settings testing.
Thank you, Ravi. So crystal ball time here for anyone who wants to jump at this one. So the question from one of our viewers is, would the market demand be sustainable for all masks, even after the global recovery from the pandemic situation? Anybody would like to comment on that? I think it's a great question. Merrick, you're just making a commitment here financially, so why don't you step in here and say, what does your crystal ball tell you?
Honestly, I think it's probably in the long term, I think people will forget about this and go back to the reliance on the lowest cost producer. That's my pessimistic long-term view. It doesn't mean I don't think it's a worthwhile investment now. And I do hope that, that there are policies put in place that do incentivize, or at least in some way assist, Canadian researchers and manufacturers to maintain some type of self-sustainability here. But yeah, honestly, I just think, are you going to want to buy a mask from me for 40 cents a mask, or would you want to buy one for 10 cents a mask? Of course, there's, made in Canada. There's big fans of made in Canada products, but at the end of the day, I think the bottom line will matter.
Okay, all right. Thank you for that.
I think
go ahead.
Can I add? So I think that's right in the sense that longer term, when normalcy returns, people are going to go to low cost, except if we provide value addition. That's the part of it that we need to look at from a Canadian manufacturing, is that Derek identified these ratings, which was greater than 95, better breathability, which was 5 to 6 or so in terms of pressure drop and so on. The advantage in having a superior product is that you can charge more, right? So the model is very similar to Apple versus other cell phone providers. Apple has a smaller market share, but It is capable of charging a premium, and it's probably one of the few phone manufacturers which is making a profit, right? And that is sort of the approach that we need to look into in terms of PPEs, in the sense that if Canadian PPEs are able to produce 100% filtration with ease of breathability, again, going back to the example of our medical colleagues, they have to wear N95 for 8 hours, and this is suffocating, right? And it is suffocating because what you're doing is you're breathing onto the mask, and the air that you're breathing out has high carbon dioxide in it. And so if you don't effectively clear that air and bring in fresh air, what you're doing is you are in a hypoxic condition, right? And if you're staying like that for 8 hours, you're feeling completely exhausted, your decisions are being affected, and so on. So if we drastically come up with a solution that can have the same level or superior level of filtration performance, but is very easy to breathe through, right? Then that is a much superior product that can sell very well, even if it is twice the cost, right? And that value addition is what we need to aim at over the long term. So this provides us an impetus to start this industry in the short term, but in the long term, through research and development, we need to get a superior product that anybody in the world would buy and brand it as a Canadian product.
Perfect. Thank you, Ravi. And at that, I know there's lots of great questions here. I also want to highlight, thank you, Nancy, for highlighting the fact that the Ontario government also has a website, ontario.ca/PPE as a buy and sell site. So just a note there. So I'm going to, unfortunately, we're a little bit over time, so I'm going to kind of cut it off there. There is, Kim, do you mind just moving to the next slide, please? I know that there was a number of questions about contact details for all the speakers. Obviously, that slide is here. We are recording the event as well. The slides will be available. So there's an opportunity for you to get in touch with all of us. But I just to wrap up, I guess from our perspective, the objective today was to illustrate the need for domestic supply and mass production. I think we can all agree that that was achieved today. But the other part of that we showed this is that this is not by any means simple, right? It's a complex group of a number of companies coming together in order to finally produce a product out the other end. So what it illustrates is that I wouldn't say we're done yet. We're actually probably more like at the beginning of this exercise. So there's some good hard work to be done going forward. But please join me in thanking our speakers who've all provided incredible insight in what they do. Thank you all. I do appreciate that. I'd also like to thank my awesome marketing and communication colleagues, and there's a number of them, for their tireless effort in making this happen. I know there was slides going back and forth on the weekend, and I do really appreciate that. So thank you to my colleagues. And finally, to you all for joining us today. We welcome any feedback you might have on the session, and hope to be in touch soon. So stay safe and be well. Thank you.
Thank you very much.
Thanks very much.
Thanks, everyone.
Thank you.